Hello everyone. Today we'll continue in carbonyl compounds chemical reactions, and we'll start with nucleophilic addition with hydrogen cyanide. Here we can see that we are going to add something to my carbonyl compound, because carbonyl compounds, they are what? They are unsaturated compounds, so we will add to them in order to make them saturated. Okay, and the type of the addition is nucleophilic, so I will add nucleophile to my carbonyl compound. And my nucleophile is what? Is hydrogen cyanide. Hydrogen cyanide, I will start preparing it using reaction vessel, or inside a reaction vessel, using reaction between what? Sodium cyanide. I will react it with diluted hydrochloric acid. It will form what? Hydrogen cyanide and other products. I will use this hydrogen cyanide as my nucleophile to add it to the carbonyl compounds. The general equation, I will put here a carbonyl compound. This carbonyl compound is what? It's aldehyde. Yes, it's carbonyl attached to what? To a hydrogen atom at the end of the chain. So it's aldehyde. I will add to it my hydrogen cyanide. The products will be what? Assume I will open this double bond and I will add to that oxygen a hydrogen from here, and the cyanide will be added to the other bond. So here we are forming what? Carbon attached to hydroxyl, and in the same time it's attached to what? To a cyanide compound or a cyanide group. We call this compound nitrile. Okay, it's compound that contains nitrile. I draw it in a color red in order to show the nitrile functional group. Okay, guys, this type of this reaction or addition reaction, I'm increasing my carbon chain by one carbon. Here I have fixed number of hydrocarbon chain or carbon atoms in my chain, but when we add that nucleophile, I'm adding a carbon, so I'm increasing the length of the carbon chain. Okay, so keep in your minds the addition or nucleophilic addition with hydrogen cyanide, it will increase your chain with one carbon. Okay, now this nitrile or that formed nitrile, we can do for it two types of reaction. We can do for it hydrolysis. What's the meaning of hydrolysis? It's breaking down your compound using what? Water. Okay, so we can do for it hydrolysis in the presence of diluted hydrochloric acid. Okay, so this is the acid and this is my nitrile compound. I will hydrolyze it using water. This hydrolysis will form what? It's what? This is carboxylic acid functional group, carboxyl functional group. So I will form carboxylic acid compound plus ammonium ion. So by hydrolysis, I will form carboxylic acid. Or we can do reduction for that nitrile using what? In the presence of sodium plus ethanol, this will form what? I can see here, this is the equation. We can see here, this is the nitrile group. I can reduce it. This is hydrogen in order to show we have reducing agent. So reducing agent will be 4 atoms of reducing agent. By this reducing agent, I will reduce my nitrile to what? To amine. So I will add 2 hydrogen to that carbon atom. So it will form CH2, and that nitrogen, the hydrogen, 2 other atoms of hydrogen will be added to it to form the amine group. So by reduction of my nitrile, I will form amine. Okay, this is the general equation. Again, general equation, addition of hydrogen cyanide, it will form nitrile. Okay, this is the main principle for that addition. Okay. The mechanism. The mechanism of that type of chemical reaction or addition, you have to know that that carbonyl group, it's polar group or polar. We have a polar bond because of the difference in the electronegativity between the carbon and the oxygen. Which one is more electronegative? It's oxygen. So oxygen will gain partial negative charge and carbon will gain partial positive charge. Step number 1, this addition contains 2 steps. Step number 1, the cyanide ion will attack, this is the nucleophile, it will attack the positively charged carbon, okay? This is the attack, and we will see a breaking for the double bond here between the carbon and the oxygen will gain the pair of electrons, okay? So cyanide will be added to that carbonyl group by attacking the partially positive carbon, and a pair of electrons inside the double bond will be gained by the oxygen, and we will form an intermediate by that attack. We can see here the cyanide ion, after attacking the partially positive carbon, it has been added here, and we have heterolytic fission. It's heterolytic fission. The oxygen gained a pair of electrons from the double bond, and we form an intermediate. This intermediate, negatively charged intermediate, it's very reactive intermediate, okay? So it will attack what? A hydrogen atom in other hydrogen cyanide molecule. So that oxygen will attack the hydrogen always. We have a rule that negative, always it will attack the positive. So the negative oxygen will attack the hydrogen, here the hydrogen ion, and it will accept it or gain it, okay? And here we will see a heterolytic fission. This is the arrow for the heterolytic fission between the hydrogen and the cyanide, and we will form another cyanide ion. So we have 2 steps. Step number 1, it's the attack of the cyanide ion for the carbonyl group, and we will form an intermediate. That intermediate will attack another hydrogen cyanide molecule, and it will gain its hydrogen by its attack to form what we call this compound. This compound, as we mentioned before, it's nitrile. But we have here what? We have a hydroxyl group. In order to name nitrile groups, I will start naming from the carbon that is the nitrile, the group of the nitrile. So I will start naming from it. So 1, 2, 1, 2. So this is 2-hydroxynitrile compound, okay? We call this compound 2 because we have here 1 and here carbon number 2. So we call it 2-hydroxynitrile compound. Guys, you have to keep in your minds that all aldehydes and ketones, they will form that type of compounds, 2-hydroxynitrile, okay? Except what? Methanal. In methanal, we will form a compound that contains 2 carbon atoms. So no need to mention number 2. Let's see the equation. Here we have the methanal. Okay, that methanal, if we add to it a hydrogen cyanide, the hydrogen will be added to that oxygen, and cyanide will be added by the other bond to that carbon. So we will form that compound. In order to name that compound, carbon number 1 and carbon number 2, okay? If we start numbering that compound, it contains 2 carbons. So no need to mention that at that carbon we have hydroxyl, okay? So we will name it as what? Hydroxy ethane, because we have 2 carbon atoms, hydroxy ethane nitrile, okay? Hydroxy ethane nitrile. Let's take another example, guys. If we have ethanol like this is what? Ethanol. Why? Carbonyl compound with hydrogen atom bonded to that carbonyl, okay, at the end, and we have 2 carbon atoms. So in order to solve that equation, I will add a hydrogen atom to that oxygen, and cyanide will be added to that carbon to form that compound. Okay. To name that compound, I will start numbering my chain starting from what? From the cyanide. So this is carbon number 1, 2, and 3. We will call this compound 2-hydroxy propane nitrile. Okay? 2-hydroxy propane nitrile. Okay, let's take that compound. What we call this compound? It's carbonyl attached to two alkyl groups. I will start naming it from the side nearer to my carbonyl. We have equal distance, so I will start from, it will be the same to start from this side or that side. Okay, so I will start from that side. It's what? 1, 2, 3. It's a propanone. Okay, this is ketone. When we add hydrogen cyanide, I will add for this oxygen a hydrogen atom, and cyanide will be added like this, and the CH3 will remain as it is. How can I name that compound? I will start naming it or searching for my chain like this. I will search for a continuous chain. Okay, so we have 1, 2, 3. It's 2-hydroxy, 2-methyl. You have to follow the order of alphabetical, the alphabetical order in order to name your compound. So hydroxy and methyl, hydroxy will be mentioned first. So it's 2-hydroxy, 2-methyl propane nitrile. Okay, guys, if I ask you to write the mechanism for that equation or for that reaction, I will start with what? Propanone. It contains a polar bond. Here we have positively charged and here we have negatively charged, and it will be attacked by what? By a cyanide ion. Okay, and we have to draw this arrow, and that bond will be broken in heterolytically, okay, to form my intermediate. My intermediate will be like this, C with oxygen, and it has a pair of electrons and negative charge, and we have CH3 with CH3 as it is without changing, and the cyanide ion has been added to my compound. This compound, the oxygen from it will attack the oxygen from that CH3, and Cn. Here it will attack a hydrogen ion from other cyanide or hydrogen cyanide compound like this. Okay, and the bond will be broken in order to add this hydrogen to that compound. So I will see my formed nitrile, which is, we call it 2-hydroxy, 2-methyl, okay, propane nitrile. That's it. I hope you understand all of the points we have mentioned here. The mechanism, you have to study it and you have to practice to draw the arrow in order not to forget any of them while you are writing your mechanism. And you have to know all of the conditions and keep in your mind that the addition for any carbonyl group or carbonyl compound, it's a nucleophilic addition. Okay, so I'm going to add nucleophile to my carbonyl compound. Thank you and see you later on. Bye.